At full employment, real GDP equals potential GDP, and the unemployment rate equals the natural rate. Y is real GDP, Y is subscript FE is full employment or potential GDP. UC is cyclical unemployment and is equal to 0. Economic growth is 3 to 4%. The inflation rate is 2%, and overall unemployment is 5%. Potential GDP and the natural unemployment rate are determined by real factors and are independent of the price level. Real factors are miles of railroads, miles of highways, factories, bridges, etc., and resources. Changes in the quantity of money change nominal GDP and the price level, but have no effect on potential GDP. Aggregate supply and aggregate demand are determined by equilibrium real GDP and the price level. Real GDP equals aggregate expenditure, which is the total amount the consumer, the firm, the government, and the foreigner spends on goods and services produced within the country's boundaries. Aggregate expenditure is consumption plus investment expenditures plus government expenditures plus net foreign expenditures. Since price level, if that rises, consumers are going to spend less money. So C and the price level, consumption and the price level, are negatively related. Therefore, aggregate expenditure and the price level are negatively related. And what we're going to do eventually is we're going to solve this function that you can't see yet. We're going to solve aggregate expenditure for the price level, and that will yield the aggregate demand curve. The consumer, again, is spending C dollars in the economy. The firm is spending I dollars in the economy, along with consumers buying new homes. Government is spending G dollars in the economy, and the foreigner is spending a net X minus M in the economy. C again is consumer expenditures. It includes durable goods, non-durable goods, and services. I is investment expenditures, and it includes business fixed investment on structures and equipment, and then residential investment on the construction of new homes. G is government expenditures on goods and services. It includes things like aircraft carriers, Air Force One, presidential limo, the FBI vehicles, etc. And then, the government usually typically buys U.S. products only because it's politically expedient. Now, the book uses N minus X. We're going to use X minus M because we're going to use an import function. So we need to split NX into X minus M. And X is exports, M is imports. X is the amount spent by foreigners on goods built in the United States. M is the amount of money spent by Americans on goods from outside the USA. Our book uses NX, like I said, to denote net exports. We can't use NX. Consumption function is the relationship between disposable income and consumer spending. Now I have graphed here data from the Federal Reserve website, disposable income and consumption over time. Notice that as consumption rises, disposable income rises. So consumption is a relationship between consumption, expenditure, and disposable income. Disposable income is denoted DI. It is aggregate income minus net taxes. DI minus real GDP, which we're going to assume is close enough to national income, or approximately equal to national income, minus T, which is taxes net of transfers, payments from government. The diagram to the right shows how consumption and disposable income increase over time. Now, getting rid of the time component, I can plot disposable income on the x-axis and consumption on the y-axis. Now, so how does this work? Well, if you look at in 1989, consumption is just above 4,500, and disposable income is about 5,200. So taking those two numbers, we can plot them right here. So these points right here represent numbers back in the early 1990s. These numbers represent numbers in the 2000, points in the 2000. Now, if you look at this scatter plot, it's pretty tight. And the consumption function is really not the line that fits this data perfectly because we're emitting a bunch of variables, which gets into emitted variable bias, which you'll learn about in advanced statistics if you take my advanced stats class. But we'll go ahead and assume that this is the consumption function. It's essentially, intuitively, the line that fits this scatter plot. Now notice that half the points are about above the line, and about half the points are below the line. An equation for this line can be derived using the point-slope equation, just like we did in Lecture 1 with demand and supply. Now, I'm not using points, blue points. I'm using a red point that is on the red line. I'm doing that further away from, I want to pick 2 points that are on the red line that are far apart. And I also pick points that are convenient. Like, for example, when disposable income is $7,500, consumption looks like it's $7,000. I picked 5,000 and 4,500. Those are really convenient, nice numbers. So the slope is the rise over run. The rise is, we're moving from 4,500 up to 7,000. So that's the rise. The run is, we're going from 5,000 to 7,500. So we got, when consumption is 4,500, disposable income is 5,000. When consumption is 7,000, disposable income is 7,500. So we have a rise of 2,500 and a run of 2,500 for a slope of 1. So the point-slope equation is this. We have C minus C0 equal to the slope times disposable income minus disposable income at one of our points. Well, the point we pick is the one corresponding to the one up here, the higher one. So at this point, it looks like consumption is 7,000 and disposable income is 7,500. And remember, the slope was 1. So doing arithmetic, the consumption function is just equal to DI minus 500. Now the slope of this, remember, is 1. 1 times DI is DI, so we don't even have to write the 1. And we want to check to make sure we did it right. So when disposable income was 5,000, we should get 4,500, and sure enough, we do, right? 5,000 minus 500 is 4,500. Check again. Plug in 7,500, we should get 7,000. Sure enough, 7,500 minus 500 is 7,000. So we did the math right. Now the slope of the consumption function is called the marginal propensity to consume. Now suppose the MPC for some reason was 1 instead of 0.75. It's easier to interpret 0.75 than it is 1. Okay, so the way we interpret it is we put MPC is just a change in C over the change in disposable income. And in this particular example, it equals 0.75, so we put 0.75 over 1. And notice the stuff in red and then notice the stuff in blue. Well, the stuff in blue says consumption increases by 75 cents. The stuff in red says disposable income increases by $1. So what does that mean? If government cuts your taxes in a way that gives you an extra dollar of disposable income, what are you going to do with that extra dollar of disposable income? Well, you'll consume 75 cents of every dollar that you get that your disposable income increases by. Well, that means you're going to save 25 cents. So your marginal propensity to save would be 0.25. Your marginal propensity to consume is 0.75. So the marginal propensity to save is generally equal to 1 minus the MPC. The intercept of the consumption function is called autonomous consumption. Now this is not the actual relationship. This is just something I do in my macro class. I would call this a simulation. We're simulating what autonomous consumption might be. Wealth is, or W is wealth or buying power of net assets. PL is the price level. Remember I said consumption and the price level are related negatively. YE is expected future income, and R is real rate of interest. Note, I want to make sure this is clear. This is not the actual relationship between autonomous consumption and wealth, expected future income, price level, and the real rate of interest. It's a memory device. It's also used in my simulation. Okay. Now, autonomous consumption is kind of like your rent. No matter what your income is in a particular month, you got to pay your rent, right? So your rent is independent or autonomous of your disposable income. Now, your disposable income, if it rises, you might take a longer shower. You might watch a bunch of pay-per-view on your cable. So those kinds of things aren't independent of disposable income. But your rent is, so it's autonomous. The general form of this consumption function is autonomous consumption, independent of disposable income, that's why it's added, plus MPC, the marginal propensity to consume, times disposable income. Now, remember, I alone, had defined A to be wealth plus future expected income minus price level minus real rate of interest. So if I plug that in for this A here, right, A is just this number plus this expression. I'm going to call this the Snarrian version of the Keynesian consumption function. Now here's an example. This is how it kind of works. It's actually quite simple. It looks hard, but it's not. Suppose consumer wealth is 5 trillion. Plug in 5. Expected future income is 7 trillion. Plug in 7. The price level is 8,000. Plug in 8. The real rate of interest is 2. Plug in 2. And the marginal propensity to consume is 0.75. Note the marginal propensity to save is 0.25. Derive the consumption function. So you just plug in the numbers and you simplify. Now we're going to graph it. So a D-level part of a test question would be to come up with the equation. The C-level part might be to graph it. So let's graph it. So let's pick some points on the disposable income axis. So we got 0 and then some number way out here. Well, when disposable income is 0, consumption is 2, right? When disposable income is, say, 8, consumption is 8 times 0.75 is 6. 6 plus 2 is 8. Now notice that at this upper point, disposable income, all the disposable income in the economy, is equal to consumption. So that must mean if we're at that point, on average, consumers are saving. They're not going into debt. They're not going into debt and they're not saving because they're consuming all of their disposable income. Now that doesn't mean that all consumers are going into debt. That some consumers aren't going into debt. And it doesn't mean that some consumers aren't saving. What it means is the amount of money that consumers are saving equals the amount of money other consumers are going into debt by. So the net effect is the economy in aggregate is saving. Okay? So to understand saving better, we're going to draw a 45-degree line in this model. Okay, and all that 45-degree line means is that if we're at the point, if the economy is at the point where the consumption function crosses the 45-degree line, the average consumer, the typical consumer, or the consumers on average, are neither saving nor going into debt. Again, that doesn't mean that some aren't going into debt. That doesn't mean some aren't saving. Together, in average, when you add everybody's consumption, or consumption minus disposable income up, when you add that up, the negatives counter the positives. So the average is 0. So economy, the typical consumer is neither saving nor going into debt. Going into debt is also known as dis-saving. Okay, now suppose the economy is at a point that on the consumption function that is below the 45-degree line. So when disposable income is 9, consumption would be, total consumption in the economy would be $8.75 trillion. So we'd be at a point below the 45-degree line. So when we're on a point on the consumption function that is below the 45-degree line, the average consumer is saving, because aggregate disposable income minus aggregate consumption is positive. So there are more consumers that are saving than there are consumers going into debt. Now, when consumption lies below the 45-degree line, say for example when disposable income is 7, consumption would be 7.25. That means we're on the consumption function where it lies above the 45-degree line. And when that happens, the average consumer is going into debt or dis-saving. Now, there are some consumers that are saving, but the amount of money they're saving is wiped out by the amount of money that other consumers are going into debt by. So let's show what happens if the consumer wealth rises to $5.5 trillion. Wealth was 5, now it's 5.5. How does the consumption function shift? It shifts up from 2, where it was when wealth was 5, to 2.5 when wealth is now 5.5. Now notice it's a parallel shift because the slope doesn't change. What happens at the price level? Remember, the price level and consumption are negatively related, like I mentioned on the very first slide. If the price level goes up to, say, 9 from 8 after wealth went from 5 to 5.5, so we're holding wealth constant at 5.5, we're holding real rates of interest constant at 2, and we're holding future expected income constant at 7. And in this scenario, we're going from $8,000 on the price level to $9,000. So at that moment in time, we're freezing 5.5, 7, and 2. And we're only changing the price level from 8 to 9. So when we do that, the consumption function shifts down. And it's a parallel shift because the slope of the consumption function doesn't change. So this is how the consumption function works. And this is basically how every model for the rest of my course works. So if you can understand it for the consumption function, then you can understand it for all of the functions that follow. Consumption will shift up if wealth or expected future increase because those things enter the intercept in a positive way. Price level and the real rate of interest have negative signs in front of them. So if either one of those falls, the consumption function does the opposite. It shifts up. Likewise, consumption will shift down if wealth or expected future income fall, but because the price level and the real rate of interest enter this equation with negative signs, the consumption function does the opposite. Because aggregate demand, aggregate expenditure, aggregate supply are all graphed with real GDP on the horizontal axis, we want to convert the consumption function into something that is a relationship between consumption and real GDP, Y, instead of consumption and disposable income. And there's a really simple trick that I'm going to use here. Now remember, disposable income equaled Y minus T. Real GDP minus taxes net of transfers. So all I'm going to do is I'm going to replace disposable income with what it equals, Y minus T. So I have MPC times disposable income here. So there's nothing really incredible about this, right? I'm just using the definition that we came up with for disposable income, which could be a different form. You could come up with a different form if you wanted. Now, what did I do here? On an exam, you're not going to be required to do this, but I want you to understand where this comes from. So we're going to go through the steps. This will not be testable. So all we're doing is taking the MPC times Y, and then we're taking MPC times a negative T. So we're just using a distributive property here. So if we factor the MPC, we get this. If we use a distributive property, we get that. They're equivalent mathematically. Now what do? We took this thing here, this expression here, and we used the commutative property and put it in the bracket. So this is equivalent of saying 4 plus 2 is 2 plus 4. Either way, you get 6, right? So both those equations are equivalent mathematically. Now this is what I call the Snarrian consumption function because it relates consumption and real GDP. Okay? Now we're going to graph it using the same exact numbers, but now we need an additional number. We need tax revenues net of transfers. So using the same exact numbers that we did initially in the previous example, right, we're going to come up with a Starion consumption function. Well, we have to do something additional. This is what we already did this part here, right? We already did that. Now we want to do what? We want to plug in 0.75 and taxes net of transfers. And this right over here is Y, real GDP. We simplify and we get a negative intercept plus 0.75 times Y. Now if we plug in $13 trillion for real GDP, consumption is 9.5. And then we graph, or we plot that point, and we connect the dots with a line, and we label it C. Now, this is a Starion consumption function. The Starion consumption function relates consumption and real GDP. You do not draw a 45-degree line here. It makes no sense in the context of the Snarrian consumption function. Now, if you go to my website, www.halsnar.com, you can go to Excel simulations, and you can actually run an Excel simulation that I built based on this equation. Now, the import function is unique to my method of teaching macro principles. Like I said, most textbooks just model net exports as NX. We model it as X minus M because we're going to use an import function to help us come up with an aggregate expenditure, aggregate demand model. Now, money spent on domestic goods and services is C. Well, money is spent on domestic goods and services, which is the amount C. Consumers spending money on goods and services other than new homes. Well, money that is spent on imported goods and services is denoted M. M is the amount of money spent by Americans on goods from outside the USA. In the short run, the factor influencing imports is U.S. real GDP. If GDP is zero, then we can't buy any imports. Simple enough, right? So when GDP is zero, imports are zero, so that means the intercept of this function is zero. Now, as GDP rises, people increase expenditures. They buy more imports from other countries. So as we get wealthier, our imports grow. So GDP and imports are positively related. And we're going to assume for simplicity, it's linear. So the marginal propensity to import, the MPM, remember M stands for import. The marginal propensity to import is the fraction of an increase in real GDP that is spent on imports. In other words, it's the slope of this production function. So the import function is very simple. It's just the dollar value of imports equal to the marginal propensity to import times the real GDP. This table comes from the textbook. So we're going to use it to derive the import function. Now, when real GDP is zero, imports are zero. When real GDP is 3 trillion, imports are 0.75 trillion. When real GDP is 6 trillion, imports are 1.5 trillion, etc., etc. And then when real GDP is 15 trillion, imports are 3.75 trillion. The line fitting these data points is the import function. Now, the marginal propensity to import is the change in imports, right, over the change in real GDP. Now, when imports are 3.75, real GDP is 15. When imports were zero, real GDP was zero. So the marginal propensity to import is 0.25, and so the import function is simply 0.25 times y. Now, Starion aggregate expenditure schedule is found by substituting this consumption function. Notice I got rid of the brackets. I did that for a reason. And the import function. And notice the y's are in red. And everything else in the consumption function is green. Everything else in the import function is blue. So I'm going to plug the stuff on the right-hand side of the consumption function into the square brackets. I'm going to plug this stuff into here. Again, you won't have to do this on an exam. I just want you to understand where this thing comes from. This is not testable. So we're going to plug that into the square brackets. We're going to plug that into the squiggly brackets. If you can load a toaster with bread and then butter your toast, then you should be able to understand this, because that's all we're really doing. We're just toasting some bread. Here's the toast. We have 2 pieces of bread, and then we have a grilled cheese sandwich. We take our toast and put cheese in between, and we have a grilled cheese sandwich, essentially. Now we're going to collect the y's. Okay, so again, we're going to use the commutative property. 4 plus 2 is 2 plus 4, right? So we collect the y's, and we put everything else in the square brackets. So these things get put in the square brackets. This thing gets taken out. And again, this is just like taking 4 plus 3 plus 2. And that equals 3 plus 2 plus 4. So we're doing nothing new here. These two steps are equivalent. Now we can factor out the y. That's why I had them in red. We can factor them out. Undo the distributive property, right? We can factor out the y's, and that's doing the distributive property in reverse. Okay. Now notice everything that is in green is consumption. Everything that's in blue is imports. So we have consumption plus imports plus government spending plus exports minus imports. That's the same thing as it's up here. Now this is what I call the Snarrian aggregate expenditure schedule. And this will be on your equation sheet for the exam. Now, using the same exact numbers that we did before, we need to assume numbers for investment expenditures of $1 trillion, government expenditures of $3.5 trillion, and exports of $0.5 trillion. And the marginal propensity import is 0.25. Remember our little numerical example? So all we're going to do is plug in the numbers. $5 trillion in wealth, $7 trillion in future expected income, $8,000 in the price level, 2% interest rates, marginal propensity to consume of 0.75, taxes net of transfers, $3 trillion, investment expenditures of $1 trillion, government expenditures of $3.5 trillion. Note, taxes net of transfers are 3, government spending is 3.5, so we have a budget deficit here. Exports are 0.5 trillion, and the marginal propensity to import is 0.25. Arithmetic yields the aggregate expenditure equation 4.75 plus 0.5y. If real GDP is 0 in America, then our aggregate planned expenditure is going to be $4.75 trillion. Now, if real GDP is $9.5 trillion, aggregate planned expenditure is, well, 9.5 times 0.5 plus 4.75 is 9.5. Now we're going to plot the points in the grid to the right. Point 1, remember, was what? Real GDP was 0. Aggregate planned expenditure was 4.75. Okay, so we find 0 on the y-axis, which is, horizontal axis or the x-axis. We find 0, then we go up until we get to 4.75. Point 2 is way out here, somewhere out here, right? 9.5. Now in your homework, I'm going to give you an actual grid. I'm going to give you some graph paper on the homework, so it'll be easier to graph. So real GDP is 9.5. Aggregate expenditure is 9.5. So that point must be on the 45-degree line, right? Remember that from the consumption function? Right? So the next point should be on the 45-degree line, because real GDP equals aggregate expenditure, and anywhere on the 45-degree line, that's the case. Right? So the aggregate expenditure, the aggregate expenditure model passes through those 2 points. Now this is actually aggregate planned expenditure. Okay? Now since aggregate planned expenditure equals GDP at this point, the change in firms' inventories equals the plan change. Okay? So what does that mean? When the economy is at this point, what that means is, for example, if you're an IHOP manager, a manager of an IHOP restaurant, and your customer traffic is such that the flour that you use to make your pancake batter, right, each hour your pancake flour drops by, say, 50 pounds, right? And you are ordering 50 pounds of flour every hour. Well, your pancake flour is being depleted by 50 pounds an hour, and you're replenishing your pancake flour by 50 pounds of flour an hour. Okay? So the change in firms' inventories equals the plan change. Okay, suppose real GDP is actually $12 trillion. Aggregate planned expenditure would be then $10.75 trillion. And notice that the red dot is below the 45-degree line. So what is going on here? Aggregate planned expenditure is less than real GDP, the output of the economy, right? When aggregate planned expenditure is less than real GDP, an unplanned increase in inventories occurs. So let's think about this. You're an IHOP restaurant, right? And your customer traffic, right, starts to slow down, right? Your customer traffic starts to slow down, right? So you see your flour inventory that you use to make pancakes, the flour inventory starts to rise, right? Because your customer traffic's slowing, right? And so your flour is starting to pile up in the back room where you keep it. So what do? You call your supplier of flour and you say, look, my customer traffic's down. Instead of using 50 pounds an hour, I'm only using 20 pounds an hour. So can you reduce my replenishment rate by 25 per hour, right? So what you're trying to do is you're trying to match your planned expenditures with the depletion rate, right? You're trying to replace your inventory repletion rate. You're trying to match your inventory replenishment rate with your depletion rate. Okay, so what happens is firms cut production, right? They start producing. Your IHOP restaurant stops producing as many pancakes, right? You slow down the production, right? You slow down the production. Your inventories start rising. Then you start cutting your inventories, and this happens until the replenishment rate equals the depletion rate. Now let me ask you a question. As a manager of an IHOP, do you need government to tell you to do this? No, you don't need government to tell you to do this. When you see your inventories rising unexpectedly, right? What are you going to do? You're going to call your suppliers up and say, hey, I don't need as many of these resources to make my product. You don't need government telling you that, right? You're smart enough to figure that out on your own. So markets work, right? People are smart enough. They know if they don't change the replenishment rate, all of a sudden their flour bin's going to overflow, and they're going to throw away flour, and they'll get fired over it, right? And people don't want to get fired. Okay, now suppose real GDP is 8 trillion instead, right? So aggregate planned expenditure is what? 8.75 trillion. So aggregate planned expenditure is greater than real GDP. What's going on here? When aggregate planned expenditure exceeds real GDP, an unplanned decrease in inventories occurs, right? So firms raise production, real GDP increases until it reaches equilibrium. So let's think about this. All of a sudden, you start noticing traffic in your restaurant at IHOP is building, right? Now you're making more pancakes than what you had expected. So what happens to your flour inventory? Well, your flour inventory, you're starting to consume 50 pounds an hour of flour, right, instead of 25. So you're seeing your inventories drop, right? So what do? When you start seeing your inventories drop below or drop more rapidly, you call your supplier and you say, hey, bump my replenishment of flour up by 25 pounds an hour, right? So you start ordering more flour. Your planned expenditures rise, right, to meet the new output, right? So the economy is expanding. That's exactly what's going on here. And so you keep upping your replenishment rate until it equals the depletion rate. And we've achieved equilibrium. Now, you didn't need government telling you to do it, right? If you don't replenish your flour, what's going to eventually happen? You're going to run out of flour, and your customer's going to be upset. They're going to leave in a huff, and you're going to get fired. And because you're self-interested and want to keep your job, you're going to make note of your flour inventories dropping to prevent being fired. Okay, now let's ask a question. What happens if government spending is increased to $4 trillion, right? Democrats are always proposing to expand government spending to fill the hole left in aggregate demand by consumers that aren't spending, right? We hear that all the time. So they tend to pass bills that increase government spending. Okay? So what do? Well, government spending was 3.5 trillion, right? What is it now? It's 4. It was 3.5, now it's 4. It was 3.5, now it's 4, right? How does this affect aggregate expenditure? Well, the aggregate expenditure model goes, the intercept goes from what it was, 4.75, to 5.25, right? Now the slope hasn't changed. So it's a parallel shift upward in the aggregate expenditure model. Now let me ask you a question. Is aggregate expenditure in equilibrium? No. Aggregate planned expenditure is greater than real GDP. Why is that? Well, going back to IHOP restaurant. You notice that your flour is falling, right? So you start increasing the amount of flour that you buy from your supplier. And you do that until your replenishment rate equals your depletion rate. And so the government is hoping that this unplanned decrease in inventories, right? Because you see your flour inventory fall because of the increased foot traffic in your restaurant, right? So you have this unplanned decrease in inventories. You have to up your replenishment rate until it equals your depletion rate, right? So you're buying more from your suppliers, and if every business is doing that in the economy, then real GDP and aggregate planned expenditures will once again equal themselves. And in this scenario here, depletion rates equals replenishment rates of inventories. So what happened to real GDP? It went from 9.5 to what? Well, it's calculated, right? How do you calculate this new equilibrium? Well, at this equilibrium, real GDP equals aggregate expenditure. That's why we made this substitution here, right? We're assuming by replacing AE with Y here that we're in equilibrium. All right, so what happened here? Well, we took 0.5Y and subtracted it from this side, leaving 5.25. We subtracted 0.5Y from 1Y. 1Y minus 0.5Y is 0.5Y. Now we divide both sides by 0.5 and real GDP becomes 10.5 trillion, right? So what happened to real GDP? It increased by 1 trillion, right? So government spending went from 3.5 to 4. GDP went from 9.5 to 10.5. So the government spending multiplier is the ratio of the increase in GDP divided by the change in government spending. This is what government did. This is how the economy responded. So the government spending multiplier here is 2. So what does that mean? We'll put this over 1. 2 divided by 1 is 1, right? So each additional dollar spent by government results in a $2 increase in real GDP. Now, this comes at a cost, right? Increasing government spending, raises the $500 billion budget deficit to $1 trillion. So there is a cost here. Okay. Now, suppose instead Republicans get their way and they cut taxes by 0.5 trillion. So instead of this going up from 3.5 to 4, the 3 goes from 3 to 2.5, right? So how does this affect aggregate expenditure? Well, the intercept the intercept rises from 4.75, what it was, to 5.25. Okay? Again, aggregate planned expenditure is greater than real GDP, which means there's an unplanned decrease in inventories. What does that mean? Well, when your business starts picking up, you see a decrease in your inventories, and it's not planned because you were thinking that you're in a recession, right? But all of a sudden you see your inventories fall. So what do? You start calling your suppliers to replenish your flour inventory at a much higher rate, right? And if every business does that, then the economy will soon return to equilibrium. Okay? So what is the new equilibrium GDP level as a result of this tax cut? Well, remember again, on the 45-degree line, aggregate expenditure equals real GDP. So we got to replace this with Y. So step 1 in finding a new GDP level is what? Replace an AE with Y. And then you subtract over from both sides 0.5Y. 1Y minus 0.5Y is 0.5Y. Dividing both sides by 0.5 yields real GDP at 10.25, right? So The tax cut of 0.5 trillion increased GDP by only 0.75. The increase in government spending increased real GDP by 1 trillion. The same size tax cut only increased GDP by 0.75, right? So the tax cut multiplier is smaller than the government spending multiplier using the numbers I've assumed here, right? So a $1 cut in taxes collected results in a $1.5 trillion or $1.5 increase in real GDP. Now this comes at a cost. The tax cut raises the budget deficit from 500 billion to 1 trillion. Is it worth it? Well, who's going to pay this deficit? My son's generation, when they become taxpayers, are going to pay it. Pay off our bill. Okay. So, aggregate expenditure shifts up if wealth, future expected income, investment, government spending, or exports increase. Aggregate expenditure also increases if the price level falls, the real rate of interest falls, or taxes are cut. Okay. Aggregate expenditure shifts down if wealth or future expected income or investment or government spending or exports increase. Aggregate expenditure shifts down if the price level, the real rate of interest, or taxes are cut. Okay? So anything with a negative sign in front of it, right? MPC times T has a negative sign in front of it, R has a negative sign in front of it, and price level has a sign in front of it. So anything with a negative sign in front of it causes aggregate expenditure to go in the opposite direction, right? Now, the Congress and the President are in charge of fiscal policy. Expansionary fiscal policy involves a cut in T, taxes, or an increase in G, government spending. Restrictive fiscal policy involves raising taxes or cutting G. This one's called stimulus, right? This is called stimulus. The Federal Reserve, our central bank, is in charge of monetary policy. Expansionary monetary policy involves lowering the federal funds rate, which the Fed hopes lowers the real rate of interest and increases investment. Restrictive monetary policy involves raising the federal funds rate, which the Fed hopes raises the real rate of interest, which would lower investment.